When folding phones first arrived, the promise was clear: a single device offering smartphone portability and the expansive display of a large format tablet. But hardware designers quickly encountered a geometric hurdle. When you unfold a standard bifold phone, the resulting screen is almost perfectly square. This diagram shows the problem with that shape. Because modern media is rectangular, a 16 by 9 video scaled to fit an 8-inch square leaves massive bars of uneased pixels at the top and bottom of the display. This vertical dead zone means the actual viewing area on an 8-inch foldable is often only slightly larger than what you'd see by simply rotating a standard smartphone. To address this physical limitation, Samsung developed the Galaxy Z Trifold. By using 2 separate hinges, the device unfolds twice to reach its full size. The value of folding technology relies on canvas shape, not just the raw diagonal measurement. It requires a physical format that actually matches the media we consume. Early prototypes used an accordion-like Z shape, but Samsung chose a U architecture that folds inward. In this configuration, the 10-inch internal display wraps safely inside the chassis, protecting the main screen while leaving a standard cover display accessible outside. Opening that 10-inch canvas eliminates the thick black borders found on smaller folds. When you play a video here, the image stretches to the very edges of the frame. The double-hinge design creates a 16 by 10 widescreen ratio, which aligns with the native formats of cinema and full-screen games. Aspect ratio dictates utility. By aligning the hardware with the widescreen formats used in modern media, every inch of the display becomes a functional canvas. The extra width also changes how the operating system handles professional tasks and multitasking. A 10-inch rectangle provides enough horizontal space to run 3 applications side by side without them feeling compressed or difficult to use. Native applications take advantage of this layout immediately. The file system, for instance, can display 3 full layers of folder hierarchy at the same time. This wireframe illustrates a unique software feature for this device. The Trifold is currently the only phone that runs Samsung DeX, a complete desktop interface, directly on its own internal screen. When paired with a mouse and keyboard, the wider physical footprint turns this pocketable device into a functional desktop workstation. Compressing a 10-inch tablet into a pocket-sized device requires significant engineering trade-offs. When closed, the device is 12.9 millimeters thick and weighs over 300 grams, making it feel substantially bulkier than a traditional smartphone. The internal screen is also a point of vulnerability. This side profile wireframe shows how the display must navigate 2 different folding radiuses, a tight curve on the left hinge and a wider looping wrap on the right. Powering a screen of this size is a challenge, as the partitioned chassis limits the battery to 5,600 mAh, a relatively low capacity for a 10-inch display. While screen technology has advanced, the thinness of this chassis reaches the physical limits of current lithium-ion battery density. To make future iterations thinner and longer lasting, the industry will likely need to adopt high-density silicon-carbon battery technology. With an estimated price between $2,500 and $3,000, this remains an expensive, first-generation proof of concept for a very specific type of user. However, unfolding the device redistributes its 300-gram weight across a frame only 3.9 millimeters thick, altering the way you perceive its bulk. Samsung's Trifold suggests that the endgame for mobile hardware is finding the specific physical geometry required to replace a laptop.